this is so weird. Oh my God. They're so strange. Such a strange animal.
At the deepest point on Earth, cameras caught something that should not exist. A living vertebrate moved under crushing pressure where biology was supposed to fail.
It's a big surprise. Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
That moment shattered limits, exposed hidden power struggles, and revealed that the darkest place on the planet is no longer beyond human reach alone.
Oh, you got him! Got him!
All right! No,
The discovery that broke a hard biological limit. Deep beneath the surface of the Pacific Ocean, nearly 7 miles down in the Mariana Trench, scientists believed life had reached its final limit.
Throughout most of recorded history, men had just assumed that beyond a certain level the sea was pretty flat, pretty dead, fairly lifeless.
At a depth of about 36,000 feet, the world was thought to be nothing more than crushing pressure, freezing cold, endless darkness, and stillness that felt like death itself. For decades, this belief shaped every textbook, every lecture, and every model used to explain how life works on Earth. The deep ocean was seen as a dead zone for complex animals. Only the smallest organisms were expected to survive, and even they were thought to exist barely alive, moving slowly in thick mud. Scientists believed this because the conditions were extreme beyond imagination. The pressure at that depth is more than 1,000 times stronger than the pressure at the surface. Pressure is the force created by the weight of water pushing down. At the bottom of the Mariana Trench, that force is so intense that it can crush metal and shatter machines. Human bodies would collapse instantly. Bones would break. Organs would fail. Brains would stop working. Even most submarines cannot survive there for long.
At the Mariana Trench, human life is impossible. We're not equipped to resist those kinds of pressures.
Based on everything known at the time, fish and other animals with backbones were not supposed to exist there at all. That belief shattered the moment cameras finally reached the trench floor. What appeared on the screen was not drifting debris or a lifeless shape. It was a living animal with fins, a clear head, and full control of its movement. It swam forward. It turned. It reacted to its surroundings. Its body moved with purpose and balance. This was a vertebrate animal, meaning it had a backbone, moving calmly through an environment once believed to be completely deadly to such life. The animal showed no signs of damage. It did not struggle. It did not move slowly. It behaved as if the pressure meant nothing. When scientists reviewed the footage, the reaction was immediate and severe. Shock spread quickly. Fear followed close behind. No confirmed vertebrate had ever been recorded at this depth before. This was deeper than the height of Mount Everest. Every accepted limit of life had just been crossed on camera. This created a terrifying question. Either scientists had been wrong about the deepest limits of life for generations, or this creature had evolved survival traits never seen before. Both possibilities were deeply disturbing. This discovery was not a curiosity. It was a warning. It exposed serious gaps in human knowledge. It showed that the deep ocean still hides rules we do not understand. The scientists quickly realized they could no longer trust old assumptions. They needed to re-examine the ocean layer by layer, from the surface downward, to find where their understanding had failed and how it had led to this moment at the deepest place on Earth. The long descent where life was supposed to disappear. The ocean is not a single open space. It is a layered world built in stages, with each level becoming more hostile than the one above it. As you move downward, the ocean begins to strip life of the things it needs to survive. With every drop in depth, conditions grow more violent and unforgiving. Light fades away. Water grows colder. Pressure increases relentlessly. Oxygen becomes harder to access. Reliable food sources begin to disappear. Each meter deeper makes survival more difficult and more dangerous. Near the surface, life still feels familiar. From the surface down to about 200 meters, sunlight passes through the water. This light allows plants and algae to grow through a process called photosynthesis, which means they use sunlight to make energy. That energy feeds plankton. Plankton feeds small fish. Small fish feed larger predators. This zone is loud, active, and crowded with life. Movement is fast. Energy is plentiful. Survival is competitive but possible. Below this layer, everything changes quickly. As depth increases, sunlight weakens and then vanishes entirely. By the time you reach 1,000 meters, complete darkness takes over. No sunlight means no plants. No plants means the entire food system collapses. Life here depends on scraps that fall from above, such as dead organisms and waste, or on chemical energy released from the Earth itself. Food is rare and unpredictable. Every meal matters. As the descent continues, temperatures drop toward freezing. Pressure increases at a rate that breaks metal and crushes machines. Oxygen levels fall. Animals must slow down to survive. Between 1,000 and 4,000 meters, creatures are forced to conserve energy constantly. Bodies become softer and less rigid to handle pressure. Many animals create their own light using bioluminescence, which is light produced by chemical reactions inside their bodies. This light is used to find food, avoid danger, or communicate. Here, every movement is controlled. Nothing is wasted. Below 4,000 meters is the abyssal zone. This is a place of near stillness. Food arrives only as tiny particles drifting down from far above. Most creatures barely move at all because movement costs too much energy. Large animals are rare. Everything here is built to survive with almost nothing. For a long time, scientists believed this was close to the absolute limit of complex life. But even this was not the deepest layer. Beyond 6,000 meters lies the Hadal zone, found only inside deep ocean trenches. For decades, scientists believed this zone could not support complex life. The pressure here is so extreme that it damages proteins and interferes with basic cellular functions. It was believed that bones could not hold shape, organs could not function, and nervous systems could not survive. Only microscopic organisms and small invertebrates were expected to exist. But that belief completely collapsed when the fish-like vertebrate was recorded at 36,000 feet in the Mariana Trench. This discovery proved the Hadal zone was not empty. It was not dead. It could support structured bodies, functioning organs, and controlled movement under pressure once thought impossible. The consequences were massive. Biology had to be questioned. Long-held limits were no longer reliable. Scientists knew they had to return to the deepest point on Earth to confirm what the cameras had revealed. That place is called Challenger Deep, the lowest known point in the Mariana Trench. Challenger Deep, proof that the impossible exists. Challenger Deep is the lowest known point on the surface of the Earth.
The seafloor. It's difficult to make sense of the sight.
It sits at the very bottom of the Mariana Trench, buried beneath miles of water. Reaching this place is not a normal scientific mission. It is a direct confrontation with forces that destroy almost everything that enters them. The pressure alone is overwhelming. At this depth, the weight of the ocean presses down with more than 1,000 times the pressure felt at sea level. Even the smallest mistake can cause a vessel to collapse instantly. Water temperature remains just above freezing, and there is no light of any kind. The darkness is complete and permanent. At this depth, exploration becomes a fight to survive against the ocean itself. Humans cannot go there without extreme protection. Only a very small number of manned missions have ever reached the seafloor of Challenger Deep.
Cover the seafloor in a methodical way.
Each mission required years of planning and engineering. Special submersibles had to be built with thick reinforced hulls designed to resist crushing pressure.
We are about to begin the pressure test.
Every bolt, every seal, and every material had to be tested again and again. Failure was not an option. Even with all these precautions, most missions could only stay on the seafloor for a short time. Minutes passed quickly as scientists struggled to observe anything before conditions forced them to retreat upward. In more recent years, new technology changed what was possible. Advanced cameras capable of functioning in total darkness were deployed. Robotic arms allowed careful interaction with the environment. Pressure-resistant sensors collected data over long periods. Autonomous vehicles operated without human pilots and stayed on the seafloor far longer than any crewed mission could. For the first time, scientists were able not only to reach Challenger Deep, but to study it carefully and repeatedly. What they found was deeply unsettling. Clear tracks were visible in the soft sediment covering the trench floor.
It's like a baleen whale, and you can still see the baleen.
Yes, the baleen is still.
These marks were not random. They followed consistent paths and appeared again and again in the same areas. This showed movement over time. Motion sensors confirmed activity at different locations across the seafloor. The fish-like organism discovered earlier was not a lone anomaly. It was part of a population. These animals were living, moving, and interacting within the trench. This was a working ecosystem operating under pressure that was once believed to destroy complex life instantly. Samples taken from the sediment showed chemical signs of biological processes. Tissue samples from captured organisms revealed cells built to survive extreme pressure. Their muscles functioned normally, their organs maintained structure, their nervous systems transmitted signals without failure. These adaptations were not temporary. They were stable traits developed over many generations. This life had not stumbled into survival. It had fully adapted to one of the most hostile environments on Earth. The floor of the trench was not empty or dead. It was active and structured in ways no one had predicted. The central question for scientists changed completely. They no longer asked whether complex life could exist at this depth. That question had already been answered. Now they needed to understand how it was possible.
It's a happy day to be an octopus.
They needed to learn how these organisms functioned, how they moved, how they fed, and how their biology had broken rules once thought unbreakable. How life rewrote the rules under crushing pressure. Laboratory analysis of the samples collected from the Mariana Trench revealed adaptations that were beyond anything scientists had ever imagined. Every system in these creatures was engineered for survival under pressures that would instantly destroy ordinary life. Cell membranes contained specially modified lipids that kept them from collapsing under the crushing weight of the water.
Just think the amount of calories in a whale here. I mean, they're equivalent of so much marine.
Proteins, which would normally fold incorrectly or break apart at such pressures, were structured in ways that resisted deformation. Enzymes carried out chemical reactions that would stop entirely in any surface-dwelling organism. Every cellular process was protected, stable, and functioning in an environment previously considered impossible for complex life. Even the skeletons of these creatures were astonishing. Unlike surface fish, which rely on rigid bone to support movement, these animals had flexible skeletal structures that reduced the risk of fractures. Their muscles were arranged to conserve energy and limit strain, allowing movement without exhausting themselves. Every part of their bodies was optimized to survive in a place where one mistake could be fatal. The most shocking discovery, however, was their nervous system. Neural tissue showed stable signal transmission, even under thousands of times the pressure at the ocean surface. Reaction times were slower than in shallow water animals, but every motion was deliberate, controlled, and coordinated. The fish were not simply drifting or twitching. Their behavior demonstrated awareness, response to the environment, and purposeful movement. They were thinking in the most basic biological sense, and their brains were functioning perfectly under conditions that should have made thinking impossible. These findings confirmed what scientists had long doubted. Complex biological systems could not only survive, but operate normally under conditions previously believed to be fatal. Life had basically rewritten its own rules. The discovery also immediately drew the attention of governments and industries. If life could adapt to these pressures, machines and technology could be designed to follow. Robots and instruments could be built to withstand extreme depths, operate for long periods,
Jumping ship.
and explore previously unreachable zones. The rise of machines that can stay where humans cannot. Human exploration of the deep ocean has always been rare, difficult, and extremely dangerous. The pressures at extreme depths are lethal for humans and destructive to almost all equipment. For decades, the deepest trenches were considered unreachable.
The seafloor. It's difficult to make sense of the sight.
Except for the briefest, most carefully planned missions. Every dive was a gamble, and every observation was limited by time and the fragility of human-operated vessels. Even advanced submersibles could only remain at depth for minutes before the risk of catastrophic failure forced them to return to the surface. This made long-term study nearly impossible, and the trench remained largely unobserved. Robotic technology changed everything. Small autonomous machines were developed that could function entirely without human passengers. These robots did not need life support systems. They could operate for days or weeks under extreme pressure without risk to human life. Their designs allowed them to withstand the immense pressure at the bottom of the Mariana Trench, which would destroy conventional vessels or machinery. These machines could map large areas of the seafloor in unprecedented detail. Some were designed to glide through the water, navigating currents and obstacles with precision. Others crawled along the trench floor, moving carefully over uneven terrain and avoiding obstacles in ways that allowed them to collect samples, observe activity, and record video for extended periods. They worked quietly, leaving the environment mostly undisturbed while performing their tasks. The data collected by these robots revealed astonishing features of the deep sea.
Looking at methane in these bubble streams.
They discovered methane seeps emitting gas from the seafloor. They located mineral-rich nodules containing elements critical for modern technology. They identified stable areas where long-term equipment could be placed to conduct ongoing observation and experiments. These discoveries showed that the deep ocean was no longer unreachable. It was now accessible in a reliable way. It could be mapped, monitored, and explored consistently. This new reality also drew attention to the existing infrastructure and systems that lay across the ocean floor. The ability to remain at the bottom of the ocean for extended periods meant that previously untouchable systems could now be inspected, monitored, or even manipulated by powerful nations. The fragile infrastructure holding the world together. More than 95% of the world's internet traffic flows through undersea cables that lie quietly on the ocean floor. These cables carry nearly all digital communication that modern life depends upon. Every second they transmit financial transactions worth trillions of dollars, military commands and intelligence reports, government communications, emergency response coordination, satellite timing signals, cloud computing workloads, and the private messages of billions of people. Global stock markets rely on them to stay synchronized. Power grids and shipping networks depend on their timing and data streams to function smoothly. The ambition to bind continents with cables began long before the digital age. In the mid-19th century, imperial powers and trading empires sought to conquer distance itself. Britain led the charge, driven by the desire to control commerce and diplomacy across oceans. Early attempts to span the Atlantic ended in humiliation and financial ruin as cables snapped, insulation dissolved, and electrical signals vanished into noise. When the first reliable transatlantic cable finally succeeded in 1866, it reshaped history overnight. Messages that once took weeks by ship crossed the ocean in minutes. Governments, financiers, and generals suddenly possessed a new kind of power rooted in speed. The technology has changed beyond recognition, but the logic has not. Today's fiber optic cables send torrents of data as pulses of light through glass thinner than a human hair. They still stretch for thousands of kilometers across a dark and hostile seafloor. Most rest directly on the seabed, exposed across vast abyssal plains and seismic fault lines. Near coastlines, they are sometimes buried for protection, but in the deep ocean they lie uncovered, relying on layers of steel, copper, and synthetic sheathing to survive crushing pressure, corrosive saltwater, and decades of slow geological movement. Control of this infrastructure is fragmented and complex. Private technology giants, national telecom firms, and international consortia jointly own and operate the global network. Companies such as Google, Meta, and Amazon now finance their own cables to secure faster and more reliable routes for data. Maintaining them requires a small fleet of rare and expensive cable ships that deploy and repair lines using precise navigation and robotic tools. A single deep ocean cable can cost millions of dollars to build. When one fails, repairs may take months as ships race against weather, depth, and diplomatic boundaries. The danger does not end with data alone. The seabed is already crowded with pipelines carrying oil and gas that sustain national economies. Accidents and unexplained explosions have shown how disruptive damage can be, and as deep-sea robotics have advanced, the balance has shifted even further. Autonomous machines can now map, monitor, and interact with undersea infrastructure while leaving almost no trace. They can remain hidden for long periods, and when damage occurs, assigning responsibility is nearly impossible. The ocean floor has become a silent arena of competition. Once a distant frontier for science and exploration, it is now a strategic domain. Nations are no longer competing only for resources or knowledge. They are competing for control over the unseen networks that keep global civilization alive.
That connects into the cabled oceanographic observatory known as Neptune.
Second by second, in the cold darkness below. Permanent occupation and the final shift in power. Advanced global powers, most notably China, are no longer quietly speculating about the mysteries of the deep ocean. They are speaking openly and confidently about constructing permanent human installations in the most extreme depths on Earth. What was once limited to brief, high-profile research dives has begun to shift towards sustained operations with strategic implications. Humanity is preparing to establish a continuous presence in an environment so hostile that a single error would be fatal. These are not temporary research habitats lowered for a few days of observation, and they are not symbolic stunts designed to impress the public or the media. They are conceived as enduring bases that would operate year-round under pressures capable of crushing steel like paper. A permanent deep-sea base would fundamentally change the way the abyss is observed, governed, and controlled. From such a station, uninterrupted surveillance of the ocean's trenches and surrounding regions would become routine. Autonomous and semi-autonomous machines could be deployed continuously, mapping the seafloor in unprecedented detail. Undersea communication cables that carry nearly all digital traffic would fall under immediate reach. Mineral-rich polymetallic nodules, hydrothermal vents, rare geological formations, and previously inaccessible energy resources would be easier to study, exploit, and potentially secure. Control of the deep ocean would no longer be an abstract concept. It would translate into tangible influence over information, commerce, energy, and military strategy. This transformation is occurring at a time when deep-sea research funding in many Western nations is steadily declining. During the Cold War, oceanography thrived as nations competed to dominate the seas, producing legendary research vessels, pioneering submersibles, and iconic missions, such as the descent of the bathyscaphe Trieste to the Challenger Deep. That era of intense exploration and technological innovation has ended. Research fleets are aging, flagship expeditions have become rare, and fewer scientists have the opportunity to descend into the Hadal Zone. Vast regions of the seafloor remain uncharted and unmonitored. As physical presence diminishes, transparency disappears with it. Decisions about exploration, extraction, and strategic positioning are increasingly made in secrecy, favoring nations willing to invest heavily in technology and infrastructure. The consequences extend far beyond geopolitics and technology. For humans, a permanent presence in the deep ocean would alter the balance between knowledge and control. Information gathered from these bases would not be shared evenly or openly. It would be filtered through national security policies, commercial priorities, and geopolitical strategies. Entire ecosystems could be cataloged, patented, or weaponized before the broader scientific community even learns they exist. For deep-sea creatures, the implications are even more profound. Life in the abyss evolved in near-total isolation, shaped over millions of years by extreme darkness, pressure, and environmental stability. Continuous human activity would introduce noise, vibration, light, heat, and chemical disruption into an environment finely tuned to their absence. Species adapted to eternal darkness could be disoriented by artificial illumination. Slow-growing organisms might never recover from physical disturbances. Entire biological communities could be altered or destroyed before they are properly studied. What is at stake is not merely access to the planet's deepest places, but the ethical boundary between exploration and domination. Once humanity crosses that boundary, it may never be restored. Decisions made beneath the crushing pressure of the abyss could reshape knowledge, power, and life itself for generations, leaving no opportunity to reverse the consequences.
Is phenomenal.
Make sure to click the cards on the screen now for more interesting videos.